Welcome to our training video on Prisma Access Routing, specifically focusing on the backbone. Prisma Access is a key component of a Secure Access Service Edge, or SASE, architecture. Understanding how traffic moves within this cloud service is essential for effective security and performance. Let's start with the basics of Prisma Access Routing. Prisma Access is a cloud-native security service edge solution, which delivers top-tier security features like advanced URL filtering and threat prevention. It's fundamentally built on the Secure Access Service Edge architecture, combining networking like SD-WAN with security functions. For all your users and branch offices, known as remote networks, to securely talk to each other and your internal data centers. Prisma Access needs an internal system. This is called the internal service infrastructure. To build this internal network, you must define an infrastructure subnet. This private IP range acts like the foundational glue, allowing Prisma Access to create a robust network infrastructure between all your remote locations, mobile users, and data centers connected by service connections. This is the starting point for all backbone routing. This diagram illustrates the role of Prisma Access within the overall SASE architecture. On the left, we see users represented by mobile users and remote networks. They connect through a Prisma Access location, represented by node H. This connection is fundamental for accessing the core security features. This central blue box represents the SASE architecture, specifically the Prisma Access Security Core, node C, which unifies critical security functions like Firewall as a Service, Cloud Access Security Broker, Secure Web Gateway, and Zero Trust Network Access. All user traffic flows into this core for inspection and policy enforcement. The green node J represents the internal corporate resources, such as your data centers. Traffic routed securely through the SASE core eventually reaches these resources. The core takeaway here is that Prisma Access acts as the unified cloud backbone for both networking and security, routing protected traffic across all components. The Prisma Access backbone is essentially the nervous system of your deployment. It is the internal network that securely links all your remote locations and mobile users. This vital infrastructure is brought to life by allocating an infrastructure subnet, which is a private IP address range. This subnet is used internally by Prisma Access to ensure communication flows correctly between all connected elements, including branch sites and data centers connected by service connections. Crucially, the internal communication within this cloud backbone utilizes dynamic routing. Dynamic routing allows the network to automatically discover the best paths. This is primarily achieved using the Border Gateway Protocol, or BGP, which requires setting an infrastructure BGP AS number. If you don't choose one, Prisma Access uses a default AS number, which is 65,534. This visual demonstrates how the core backbone infrastructure is established. First, the administrator configures the infrastructure subnet, represented by node A. This essential configuration triggers the setup of the Prisma Access Service Infrastructure, node B, which is the internal cloud environment. This results in the establishment of the network backbone, node C, which connects mobile users, remote networks, and service connections, represented by nodes F, G, and H. The backbone relies on dynamic routing using BGP, shown in node D, for internal route discovery. We also note the crucial role of the BGP AS number, node E, which is used to identify the routes. If not specified manually, the default autonomous system number 65,534 is used. This entire process ensures that all connected network segments can reliably exchange traffic across the cloud platform. Service connections are the crucial bridges connecting the cloud-based Prisma Access network to your physical data centers or headquarters. Think of them as secure tunnels necessary for mobile users and remote networks to access your private applications. These connections rely on robust IPsec tunnels established between Prisma Access and your network device, called the Customer Premises Equipment, or CPE. To determine the path to your internal resources, you must define the routing method. You have a choice: either static routing, where you manually list every reachable network subnet, or the highly scalable dynamic routing using BGP. If you opt for BGP, Prisma Access exchanges route information dynamically with your CPE, ensuring efficient route updates across the network. This dynamic exchange is essential for maintaining connectivity and resilience across the entire topology. This diagram maps the connection between the Prisma Access cloud and your physical data center. Node A is the Prisma Access backbone, the internal network we discussed earlier. It connects to the service connection endpoint, node B, via an IPsec tunnel. This endpoint links directly to your organization's CPE, or HQ router, node C. The router then provides access to the HQ/data center resources, node D. The bottom box, the routing exchange, highlights the critical decisions for traffic flow. Routing information defining how to reach the resources in node D is provided to Prisma Access either through dynamic exchange via BGP, node E, or through manually configured static route definitions, node F. These routes enable traffic from mobile users traversing the backbone to find its way efficiently into your corporate network. Because not all company networks are identical, Prisma Access allows you to fine-tune how traffic is routed to your headquarters or data center, specifically for traffic passing through a service connection. You can choose a BGP routing preference through the advanced settings. The two primary options are default routing and hot potato routing. Default routing follows the standard BGP rules using the best path selection mechanisms. Hot potato routing, however, is designed to hand off the traffic to your organization's network as quickly as possible. Selecting the right mode is crucial and demands a strong grasp of your internal network structure to ensure optimal traffic flow and avoid unexpected issues. These routing modes primarily affect how Prisma Access leverages BGP attributes to make these path decisions. This diagram shows the crucial choice point when configuring service connections within Prisma Access. After the initial service connection setup, Node A, you must actively select routing preferences, Node B. This decision branches into two distinct operational modes. The first is default routing, Node C, which instructs Prisma Access to use the standard BGP best path selection mechanisms, Node E. In this mode, Prisma Access honors any BGP attribute advertised by your customer premises equipment. The second option is hot potato routing, Node D. This mode dictates that Prisma Access egress the traffic from its internal network as swiftly as possible, effectively handing off traffic quickly to your CPE, Node F. This choice fundamentally changes where the majority of routing intelligence resides, inside the Prisma Access backbone or within your on-premises network. Default routing is the easiest mode to understand because it sticks strictly to how BGP is supposed to work. When you select this mode, Prisma Access will use standard BGP path selection and will completely respect all the BGP attributes sent by your network device, the CPE. This means if your CPE favors a certain route based on its attributes, Prisma Access will honor that preference. A critical function here is how mobile user routes are shared. Prisma Access takes these large mobile user IP pools and automatically breaks them down into smaller /24 blocks before advertising them. To help your network differentiate where these routes are coming from, Prisma Access automatically adds its autonomous system number, which is 65,534, along with BGP community values that specify the region, like X for North America. This allows network administrators to manage routes regionally, even if the AS number is the same. This diagram shows the specifics of route advertisement in default routing mode. We start with the mobile user IP pool, typically a larger subnet like a /20, represented by Node A. Prisma Access default routing mechanism, Node B, automatically splits this pool into smaller, more manageable /24 blocks, Node C, ready for advertisement. When these routes are advertised, Node D, Prisma Access attaches two key pieces of information. It adds the standard BGP autonomous system number 65,534, Node E, and importantly, appends regional BGP community values, Node F. These community values allow the customer premises equipment, Node G, to understand the origin region of the routes, enabling more granular policy management across geographical areas despite using the same AS number. This ensures effective route differentiation in a global network. Hot potato routing is all about speed and control, specifically transferring traffic out of the Prisma Access cloud and onto your company network as rapidly as possible. This mode is ideal if you prefer your own network, not Prisma Access, to handle most of the routing complexity and decisions. To achieve this quick handoff, Prisma Access uses a trick called AS path prepending. When Prisma Access advertises routes using BGP, it deliberately adds its own autonomous system number multiple times to the route path. This makes the path look artificially longer to BGP routing logic, which always prefers the shortest path. By adding more prepends to a secondary or backup tunnel compared to the primary tunnel, if the primary tunnel goes down, the CPE instantly switches to the secondary tunnel because it then appears to be the next shortest available path. This ensures predictable, deterministic failover. This diagram visualizes how hot potato routing manipulates BGP path selection. Mobile user traffic, Node P, enters the hot potato routing mechanism, Node H. This is where the routing policy applies AS path prepending. The primary service connection tunnel, S1, is advertised with the standard short AS path. However, the secondary service connection tunnel, S2, is advertised with extra prepends, making its path look artificially longer. Since BGP always chooses the path with the fewest AS hops, the CPE HQ router, Node C, instinctively chooses the preferred path, Node K, which is the primary SC tunnel, S1, due to its perceived shorter path. This active path selection ensures the fastest egress and reliable failover when the primary path becomes unavailable, making the routing behavior predictable and highly controlled by the customer's CPE. When configuring the service connection backbone routing, traffic symmetry is a key consideration. By default, the Prisma Access backbone is strict. it demands a symmetric network path. This means that return traffic coming back from your data center must use the exact same tunnel path back to Prisma Access that the original traffic used. However, if your network devices, like your customer premises equipment, utilize advanced techniques such as ECMP or specific load balancing mechanisms, you might need to enable asymmetric routing. Selecting this option permits non-symmetric flows across the service connection backbone. While allowing asymmetric routing can lead to load sharing across multiple service connections, this load balancing is considered a best effort basis by Prisma Access, and it may fail if one of the underlying service connections experiences an outage. This diagram illustrates the two main flow patterns related to backbone routing symmetry. The top box shows the default symmetric flow. Here, traffic leaving the customer premises equipment, node A, through tunnel 1 to the Prisma Access service connection, node B, must return precisely through that same tunnel 1. This ensures a guaranteed symmetric path. The bottom box shows the optional asymmetric flow. If the CPE supports ECMP load balancing, node C, traffic can leave through either tunnel 1 or tunnel 2. When the traffic returns from the Prisma Access service connection, node D, it is permitted to use either tunnel, resulting in an asymmetric path. Allowing asymmetry enables customer-side load balancing, offering flexibility, but introduces complexity that must be carefully managed by the network administrator. Understanding routing in Prisma Access requires differentiating how mobile users and remote networks utilize the backbone. Remote networks are designed to connect to Prisma Access, forming a full mesh network with all other remote networks and service connections. This means all branches can talk directly to each other through the cloud. However, mobile user routing is different. The mobile user device forms a tunnel only with the nearest service connection. This means that for mobile users to reach a branch site, the traffic routes through the service connection, essentially following a hub-and-spoke architecture within the backbone. Internally, Prisma Access relies on IBGP or Internal Border Gateway Protocol to route traffic between its own components. For communication externally with your CPE at the data center, it uses eBGP or external BGP to exchange routes. This diagram highlights the internal connectivity patterns within the Prisma Access backbone. Remote networks, RN1 and RN2, represented by nodes B and C, establish a full mesh network with each other, and the service connection, node D. This means RNs have multiple paths for resilience and direct connectivity within the cloud infrastructure. In contrast, the mobile user, node M, connects primarily to the nearest service connection, node D, operating in a hub-and-spoke manner internally. All connectivity within this backbone relies on internal BGP, or IBGP, routing for path selection and convergence. The BGP used to communicate externally with your data center router is eBGP. Understanding this difference is essential because mobile users rely on that service connection acting as a central hub to reach other branch locations.